Okay, so this is a lesson on graphing polynomials if you were not here on ACT Day. So we have something new that's happening with these is multiplicities. If a 0 shows up an even number of times, it's going to bounce off the x-intercept. If the 0 does not repeat itself, or it repeats itself an odd amount of times, it will pass through the x-intercept, and you'll see what I mean through the examples. So here, we're going to graph this polynomial. But before we can graph it, we need to know its end behavior. So we need to know the degree of the polynomial. To do that, we count the amount of x's we have. So keep in mind that we have 1x. There are 2 x's right here for a total of 3. Now our leading coefficient has a negative, so we have a negative x to the third. So if you look at that chart I had you guys copy down on Friday, that's going to let us know that we have an odd exponent and it's a negative, which means the left side will go up and the right side will go down. So here, what our equation really looks like is negative x, and since we have a square here, there are really 2x plus 2's. So then we're just going to use the zero product property and set each one of these equal to 0. And then we solve. If you divide both sides by -1, 0 divided by -1 is 0. Minus 2 to both sides, that's going to give you x equals -2. Minus 2 to both sides, x equals -2. Now here we have the same 0 repeating itself an even number of times. There's 2 of them, which is an even number. So when we graph this, when we hit -2 on the x-axis, we're going to bounce off that point. So if I draw my x and y-axis, I label my x-intercepts. I have a point at 0. I have a point at -2. Now for my end behavior. My end behavior says the left side should go up, so my leftmost x-intercept, I'm going to draw a line going up. On the right side, it should be going down, so the rightmost point, I draw a line going down. Now, since I have an even number of -2's, I'm going to bounce at that point. So if I'm drawing a line here heading towards -2, when I hit that point, I'm going to bounce off of it, head right back the way I came. Then I got to curve it around so I can hit 0 and go straight through. So this one, once again, we're going to graph. So we need to know how many x's we really have. So I have 2 x's here and 2 x's here for a total of 4. So x to the 4th is my highest degree. Now this time, I do not have a negative sign in front of the problem, which means this is positive. So if I look at that chart, if it's even and positive, the end behavior is up and up. What my equation really looks like is f of x equals x times x, because of the x squared, there's 2 of those, and then 2x minus 5, 2x minus 5, because once again, the exponent tells me there's 2 of them. I use zero product property, and I set each one equal to 0. And now I go ahead and solve. So x equals 0 is already solved for us. So here I would add 5 to both sides. So I have 0 plus 5 is 5. Divide both sides by 2. And that's going to give me a 2.5. The same thing's going to happen on this one. I'm going to end up with 2.5. So here I have an even amount of zeros. There's 2 of them. 2 is an even number. So when I get to the 0, I'm going to bounce. Same thing's going to happen with the 2.5s. So if I go ahead and I draw my x and y axis, I have a point at 0, and I have a point at 2.5. Now using my end behavior, the left side should be going up. The right side should be going up. And now to get the part in between. Now when it hits 0, it should be bouncing off the point. So if I'm drawing my line going this way, when I hit 0, I'm going to bounce off the point, go back the way I came. I got to turn it around to hit that 2.5. When I hit that 2.5, I bounce off 2.5 and I head back up. And that's because when I have an even amount of the same zeros, that's where it bounces. All right, so for this one, once again, you define the end behavior to start off with. There's no x's here. There are 2 here and 1 here. So for a total of 3 x's. Now I have a negative in the front of my problem. That means I have a negative for my end behavior of negative x to the third. So once again, if the exponent is odd and it's negative, it's going to be up and then it's going to be down. Going to use zero product property. Negative 2 does not have an x, so I do not have to set it equal to 0. I have x plus 2 equals 0, x plus 2 equals 0, once again because the exponent means there's 2 of them, and then I have 2x minus 1 equals 0. And then I'm going to go ahead and solve each of these. I'm going to minus the 2 to both sides, so I get x equals negative 2. For this one, I'll add 1 to both sides, getting 2x equals 1. I'm going to divide both sides by 2, getting a 1/2. Now we can see here, negative 2 showed up twice. That's an even amount, so I will bounce at that point. So I go to my graph. I'm going to have a point at negative 2. I'm going to have a point at 1/2. Once again, my end behavior is telling me I'm going to go up on the left side. Right side will be going down. Now at negative 2 is where I should be bouncing. So if I draw my line this way, I hit negative 2, I bounce off negative 2, I turn around because I have to hit that 1/2. When I do, it should end up going straight through. Okay, looking at this one. Once again, we want to count how many x's we have. We've got 1 here, 3, that's total, 4, and then 5, 6. So we have x to the 6. The first sign is negative, so it's negative x to the 6. And so my end behavior is down and down. So now I'm going to go ahead and do a zero product property, but I'm going to take a bit of a shortcut. So I don't have to write this out, do as much writing. Now I do have an x here, so I have negative 2 equals, negative 2x equals 0. I have x plus 4 equals 0, and I have x minus 2 equals 0. So if I divide both sides here by negative 2, x is equal to 0. If I minus 4 to both sides, I have x equals negative 4. However, that exponent says that happened 3 times, so I should have 3 of these x equals negative 4. Then I go over here, I solve, I get x equals 2, but I have an exponent of 2 on that one, so it means there should be 2 of these x equal 2's. So if I go for my graph, I'm going to have an x-intercept at 0, a x-intercept at negative 4, and an x-intercept at 2. Now my end behavior is down and down, so left side should go down, right side should go down. Now negative 4 showed up an odd amount of times, so I'm just going to draw a line straight through negative 4. So you can see I'm going straight through negative 4. I'm going to have to curve back around to hit the 0. And 0 only showed up 1 time, so I'm going to draw my line through 0. I got to turn it back around, and I hit the 2. And you can see 2 showed up an even amount of times. There are 2 2's, so I'm going to bounce off that point. And when I bounce off that point, I end up going down, just like my end behavior told me I should. All right, last one. So here, once again, we want to count how many x's we have. We have 5 here, 2 here, and 1 here. So that's 7. That's going to be a total of 8 x's. The number in front is positive. So I have a positive value with an even exponent, so that is up and up. Once again, using zero product property, I'm going to set everything equal to 0. Now 5 has no x, so I don't really care about it. So I have x plus 8 equals 0, x plus 1 equals 0, x minus 3 equals 0. So going ahead and solve, I'll have x equals negative 8, x equals negative 1. However, x plus 1 has an exponent on it of 2. So there's really 2 of these x equals negative 1s. This is going to be x equals 3. Now, once again, there's an exponent of 5. So there's really 5 of these. And we want to write them all out. Okay, now it's time to do the graph. So we're going to have a point at negative 8. We're going to have a point at negative 1. We're going to have a point at 3. Now the end behavior is up and up. So left side, I draw a line going up. Right side, I draw a line going up. So as I draw my line, negative 8 shows up one time. So as I draw my line, I'm going to go through negative 8. I'm going to have to turn it back around to go towards negative 1. At negative 1, it showed up an even amount of times. There's 2 of them, so I'm going to bounce off that point. So when I hit negative 1, it's going to bounce back the way I came. I'm going to come back around. And when I get to 3, you can see I'm going to go straight through because my end behavior showed me to do. And you can see here I have 1, 2, 3, 4, 5. It's an odd amount, so it should go straight through 3 going up. And you've graphed.